Thank you, Chris. Can you guys hear me? Yes, okay. So let's kind of work together here. And a quick question. Do you have an idea if in this busy conference, some of the messages that are being sent to your mobile phone are not arriving because it's busy or for some other reason, or they arrive with an hour delay or a day delay, or don't arrive at all? For some of these messages coming from friends, funny messages, maybe you don't care. If it's from the airline telling you that the flight was delayed, maybe you would care. If the gate was changed and it arrives a day or an hour later even, that may be kind of annoying if you don't get that message. So the guess is nobody really has an idea about that information, if the messages are dropped or delayed, so on. The kind of funny thing is that the mobile operator that you're using your mobile phone with probably doesn't know either. The reason being is that a lot of the services are running on infrastructure that has been built, accumulated for 20, 30 years. And it was extended, somewhat modernized at telecom world pace, which is not the fastest pace. But it was designed mostly to try to pass through messages from hop to hop, from a tower to the next tower, to the data center, to the other operator if you're roaming. And if any of these intermediate hubs decides that they cannot push the message forward because of congestion or some other reason, it's usually dropped. And nobody on either end or in the middle knows what happened to that message, if it was delivered or not. Even at this, at this date, it is considered kind of exotic, fancy to implement infrastructure nodes that have the logic of storing a message and retrying for some time until it gets through. And even more exotic to have that throughout the infrastructure. It's considered a super expensive, very fancy feature to buy from traditional telecom operators. Telecom equipment vendors. But things have to change because as the price of sending a message is virtually zero nowadays, it used to be 10 cents, 15 cents some years ago. Now it's virtually nothing, right? We're all using OTT apps, WhatsApp, Line, depending on which part of the world you live in. And a lot more messages are going that direction for a good reason. You get a confirmation the message was delivered right away, or it's still not delivered, retry. You have an idea of what's going on, a lot better than a regular text message. However, the simple no-frills text messaging still is the most ubiquitous way to reach every mobile phone. Maybe I'm not using the same messaging app that you're using, depending on what our preferences are, but most definitely all of our mobile phones can receive basic plain text messages, which make them still very, very appealing for businesses that try to reach to their audience, either for discount coupons or some sort of marketing campaigns, or as I said earlier, airlines reminders or medication compliance reminders, hospital follow-up. All kinds of use cases are now surfacing and becoming economically feasible because it's so inexpensive to send messages and they're so ubiquitous. It's almost guaranteed you can reach anybody. But because of that, it's also important for businesses to know if these messages are getting across and what percentages are not, and do better at delivering these messages. So I'd like to introduce Athar Rafiq, who is with YouPhone, Pakistan. It's a company part of the Etisalat group with hundreds of millions of subscribers, mostly in Southeast Asia and Middle East. And he's in charge of innovation for the operator. I'll let him talk for himself about his journey of modernizing their network.
Thank you. Okay. Hello. Hello, everyone. Hope you are fine. Let me tell you something about YouPhone, because I think that most of you have never heard about this company. That was a local company. YouPhone is a complete subsidiary of PTCL, Pakistan Telecommunication Company Limited. That is the only and the largest broadband and landline service provider in Pakistan. YouPhone started its operations in 2001, and we have got 24 million subscriber base in less than a decade. And in 2006, as a result of privatization of PTCL, we've been acquired by Etisalat Group. Now we are part of Etisalat Group. And last year we have got a 3G license, and we are now providing fastest growing 3G network services to our customers. Earlier, as YouPhone has always focused on the services other than only voice for call and talk and SMS just to send messages, YouPhone has always focused on empowering its customers by offering them different kind of services, like for their businesses and their business communication and marketing sort of stuff. So we have got a larger volume in terms of SMS and voice that we need to cater on daily basis. So it was a challenge, as we have got for SMS, we have got 500 to 600 million CDRs per day for SMS, and that all was handled through the legacy systems via the hardware that is quite expensive, and that was not flexible enough to meet future needs. So we were a little bit worried about that, and there was a need that there should be some system that should be robust and cost effective, so we can deploy and we can use it to meet our needs and to satisfy our customers for their businesses. So as I told you, that number of CDRs, it was very expensive to handle and to control that, because there were a lot of licenses involved in that for CDR processing, their storage and stuff like that. So, would you please next? So legacy systems was complex, and it was not flexible enough to be integrated with the campaign management solutions, and a lot of cost is also involved to go for certain kind of changes over that, and it was not recommended though. So it was very expensive for us, and we were stuck there. So our prime objective was at that time to just come up with a solution that is very cost effective, robust and reliable, because reliability was mandatory at that time, because if somebody doesn't know that whether his SMS has been reached or not, that is something that is not, customer doesn't want that kind of situation from a telecom provider. So it was like that it should be also integrated in future products, like future innovation products, so we can integrate that platform with the future products. So that was the objective. Next please. So eventually we have got TeleStax SMSC, we have got their product. Initially it was very difficult for us to decide for TeleStax or for software based SMSC, because it has never been deployed on that region. And we worked on that, and we were thinking that it could be like, we have to be sure about its reliability and robustness. So we have tried that first time in Pakistan. So we started it with the limited capacity and limited functionality initially. But as we deployed it, we have got very good results. So we decided to expand it. Now we are now handling all our business SMS through this SMSC, because it is highly reliable, and we have replaced legacy expensive SMSC with this one, because it has got very good results with high reliability and with virtual infrastructure, which is quite cheap. I mean, it's inexpensive for us to expand it. It is scalable, and it is, again, highly reliable. Later on, we added store and forward feature into that SMSC, and that worked, again, well. And that gave us very good results. So we have moved all our campaigns to this SMSC, and we have integrated IBM's Unica platform with this SMSC to cater all business needs, and hence we added multiple revenue streams with this platform. Could you please? So now our future plans are like we are going to expand this platform with virtual infrastructure because our needs are increasing day by day, and our expectations are met, and we are happy with that, and our customer wants that we need to expand it. So we will expand existing infrastructure. Along with that, we are planning to go with the digital services innovation platform because we have got trust, and we want to deploy it and roll out innovative services in Pakistan. We'll link that with this SMSC as well, and with the other services like Evelyn has just mentioned for the innovative services for different enterprises. We want to roll it out for the travel related industry, for hospital and healthcare related industry, and all over like agriculture and everything like that. So we are going to deploy it for these kind of services, and also we would be allowing application to access analytics over that platform via APIs. So we can provide analytics to our customers and to the users. So at the end, I would say thank you to TeleStax and Cassandra for that, because we are now doing better just because of these guys. Thank you. Thank you.
Thank you, Atar. So you notice that a bulk of the conversation so far was about how much pain it is to actually do anything with legacy telecom infrastructure, and the chances are that almost everybody here has, unless you're in the telecom industry for a while, you haven't even thought about how to integrate telephony features into an actual business application, into a website or into a smartphone app, because it's been virtually impossible to even get to that. So how many of you have actually done that? Right, good guess, right? Nobody in this room. But then the use cases are virtually endless once you get a flavor of what is possible. Let me give a very quick example of what is possible. We talk about airlines. Let me get back into that again. So you want to change your flight. How do you do that? Call 1-800 number. First of all, go look for it. Where is it? Okay, that's the number. Then you get asked, who am I? Like, who are you? Who are you calling? What's your account ID? What's your confirmation number? And then you get transferred a few times between call centers. And then like 15 minutes later, maybe you're talking to somebody who actually can answer the question and help you with the rescheduling. And you start searching with them. It's a frustrating process. Anybody enjoying changing their airline ticket? I don't see any hands. Okay, so some airlines that are more progressive and working with companies like YouPhone, what are they doing? They're pushing their smartphone apps like most other airlines, but on top of that, once you open the app, it will show you, just like on Airbnb or modern type of applications, do you need to know anything about your flight? Do you want to change it? Okay, yes. Immediately, a conversation, a video call starts with an agent who contextually is aware that you are calling about that ticket. They know who you are on the other end, and the conversation continues from that point on. Do you want to change your ticket? Yes. And we know exactly who you are, where you're trying to get to. Let's talk about price. Let's negotiate how much it's going to cost you. End of story. It should take a couple of minutes, not 50 minutes bouncing around menus and calls and disconnecting and all that nonsense. So with that said, I'm going to come back to this discussion here of eventually we'll get to the big data. That's the whole point of this talk. But in the telecom industry, there is history there. It's a few dinosaur years behind. Quickly about the company, our mission in life is to build middleware that abstracts that legacy infrastructure craziness from a bunch of legacy vendors who don't want to talk to each other, don't want to open up their black boxes, to mainstream developers, to people that are used to programming everything they want to program the way they want to program it. We got customers in 50-something countries, and all our products are based on an open source community that we've been fostering for over 10 years, and it's been a journey. A lot of work has been done. A lot of millions of lines of code have been written, and more than likely, nobody in this room has ever heard about these open source projects. But now that it's a new era and we're getting more to the point of, yes, it's possible, it's programmable to do communication, rich contextual communication features in your apps, you'll start hearing more about this and about this little box RESTCOM in the corner, which is what developers actually interact with, the REST APIs, etc. Also, so going back to the specific scenario here with YouPhone, what we're trying to do, they're trying to sell new businesses, get new revenue from messaging services. And they couldn't do it with black boxes, way too expensive, economically impossible to enable this type of services. So what are the options? They came to us, and we had to learn our lessons because it's relatively new and unheard of stuff to do in the telecom industry. And of course, we made our mistakes. A lot of our first generation products were based on normalized, nice SQL structures, beautiful, well understood, everybody gets it. The problem, of course, is that with a mobile operator that has hubs in many cities and multiple countries, it's hard to scale, hard to replicate, hard to make it highly available, and you can write from many locations, read from many locations. So, tough luck. Learn that lesson like everybody else in this room has, probably. Then we move off to the quick answer, Cassandra, and it has SQL. So if you use the same SQL, but just change Cassandra, the database is modern, new, everything will work just fine. Well, guess not. Everybody here knows better than me now, but it didn't work out that way. So, without understanding the intrinsic way that Cassandra works, the data structures, the theory behind it, it's far from magical, right? I think we all know this by now, but we learned that as well. Even in that vertical, this applies. You need to understand the theory behind the data structures before you can do meaningful things with it. So in the specific case of passing through messages and making sure that if they don't get across right away, we would store them for a while and retry sending them for, say, a day or whatever is configured. And if they don't go through for a day, a couple of days, then they're considered useless for this particular domain of SMS marketing. So then they're discarded, but within the day period, we'll keep retrying every 10 minutes or so. And in some cases, these messages can be stored forever or for a while, for a month, two, sometimes discarded, depends on the configuration of the use case. But the actual challenge is, how do you store messages for a while and be able to pull and retry sending as there is another flood of new messages coming in? Because we're talking about hundreds of millions of messages, and they have to be pushed out to infrastructure, which may take a while to respond. It's not instantaneous, like fire and forget. You actually have to interact with this legacy infrastructure and make sure that it accepts the message. Maybe a few seconds will pass before that happens. So the load is both on the CPU, on the network, and on the database. So eventually we arrived at a structure that kind of hit the balance between what we're trying to do in terms of inserts and being able to scan quickly. And that mentality of, the natural mentality of inserting new data by rows, right, with Cassandra, it's flipped around, and you're encouraged to insert new columns. But then that cannot be random, you have to be thoughtful. These rows have to be based on the patterns of reading. So eventually what worked out well at the end is rows based on the destination mobile number where the message is going to, and a time slot within which these messages were being attempted to be sent. So essentially every 10 minutes, we would scan through these rows and all attempted messages to certain numbers we brought in and retried. And if that retry failed a few times, then we moved on to a different sort of table, which is set aside for greater delays. And in the ones that succeeded, will be moved on to yet another data structure for longer-term storage. Probably one of the bigger lessons learned here was that deletes are horribly, horribly slow if they're not designed well. And for the most part, these SSL tables with thumbstamp markings can create a lot of junk because this is such a temporary data. It comes in and most of the time it goes away quickly, but sometimes it takes a couple of hours. So just marking for deletion creates a lot of garbage, and it's very space inefficient. So what we've learned is to create data tables by the day. So every day is for itself. And once we pass time-wise on to the next day, whatever is left out unsent from the previous day will be retried again. And if it failed, it will come into the new day's data table. And the previous day would be soon afterwards dropped. The whole table would be dropped. So it's one big chunk of data structure that just goes away and frees up space. With these slides, I wanted to kind of show that in the sense of robustness and high availability and fault tolerance, there are multiple layers of that in a telecom network. The database is extremely important, performance, failover, etc., but it eventually comes as one of the layers of high availability. Before we even get to that, there are the layers of integrating with the core network nodes, the layers of the middleware logic, of being able to understand multiple protocols for messaging, being able to translate, and being able to handle failures at that level, at the application server level. Because on one side, there are multiple applications, say, marketing campaigns of different kinds with different business logic that would interact with the messaging layer. So that itself has to be robust and fault tolerant. And this kind of diagram is somewhat simplified, but it does illustrate on the far right side, the core SS7 network elements. The messaging middleware is kind of in the middle, the red boxes, and the applications, which are in terminology, it's called ESME, and I forgot what it stands for. It's the marketing apps. And then we arrive to the data storage, the fault tolerance for that, and the implementation, which is where finally Cassandra does make life a lot easier once we figure out how to correctly use it. It did make it almost transparent to scale, to have nodes in different cities and different regions, and not worry about how they actually sync up with each other and fail over. A lot of the logic that used to be in previous generation messaging middleware platforms, a lot of the logic that used to be in those messaging servers for data fault tolerance and replicating data is now pushed into Cassandra. Big relief, huge relief. So a couple of the lessons learned at the end is, I mentioned that earlier, no way of magically taking SQL that used to work and expecting it to work with minimal changes on Cassandra and expecting it to work efficiently. The SQL had to be completely rethought out. The querying, the way that data structures work had to be well understood and redesigned. And understanding the write and read patterns for this operational data eventually was important. In terms of the complexity of the technology of what we've done is not anywhere near some of the latest cutting-edge big data operational use cases that we see in the IT domain. For like the previous topics session here was on security, fraud prevention, real-time indexing, really interesting advanced cases. The telecom world is a few generations behind. So this implementation was sort of a baby step, but it did open the minds of a lot of people in the industry to what is possible to come, what kind of things can be actually done in the future, which were completely impossible in the past. I've asked this earlier, but I'm kind of reminding it again. Anybody in the telecom industry, ask them, how do you get data out of an Alcatel box, CDRs, or any kind of interesting information aggregated over time? The answer is, who knows? Like, definitely not through REST APIs. Maybe there's some slide somewhere that shows it's possible. But now with transparency, with open source implementation, and tons of documentation and communities out there demonstrating the tremendous innovation, tremendous new ways of doing analytics and big data, and connecting that finally in the telecommunications networks, the possibilities for what can be done are starting to really look interesting. I've just listed a couple of use cases that we've already discussing with YouPhone and some other customers. Most websites still show 1-800 number. And even though you have 2,000 companies that would sell you intelligent, very interesting information about web marketing, automation, marketing analytics, and help you convert visitors to paying customers, HubSpot and Eloqua, all kinds of useful, good products are out there. With the phone calls, even though a phone call has a much, much higher chance of converting to a sale than a website visit, there is very little that companies know what to do with that phone call. It usually goes to 1-800, to some menus, some time of frustration, going through menus and connecting to some agent who may or may not be aware of what you're calling about. And this is time wasted. This is opportunity wasted. With what we've started doing, it doesn't have to be 1-800 number. It can be a unique number for the landing page. It can be a click-to-call. It can be a WebRTC widget. It can be within a certain app link that would establish a conversation. But the point is that within that context, now it's possible to merge information available about the user behavior with the calls, with the messages, information. And that together becomes even more valuable to make decisions about what's the next step, how do you help this user to become a customer. So that's just the sales kind of scenario. With support, similar situation, right? If you're using a web portal for support tickets, it's kind of contextual. It's a little frustrating to go through login and find a ticket, open a ticket, but it works. It's relatively established workflow. Most businesses would sell for a higher premium the ability to call as opposed to open a ticket online. And that kind of makes sense. You're talking to a live person. But still, most of the time you're calling a 1-800 number, some generic line, and you still go for a few minutes of figuring out who's calling and what are they calling about. That's not necessary. That can be improved dramatically with merging context into transparent data, into accessible, programmable APIs. And actually proactively help. So one of our customers focuses on that type of solution. They'll proactively ask a person who's wandering around the support pages of a website and ask them, do you have questions about the area that you're looking at? You know, better experience, better loyalty, better brand, on and on, benefits of that. Many other use cases. Arthur, do you want to add some additional ideas of that you've been kind of thinking about that are possible?
Yes, there are a lot of innovative ideas actually where you can reach your customers and your business partners for valuable innovations, like you can add marketing related. That is quite popular in Pakistan, that there are a lot of small and medium enterprises. They want to reach to their customers as well, so they can integrate with this solution, and they can get analytics as well, where they have sent their text and what is the condition now, and what is the real statistics, that how many of those text messages have been delivered successfully and how many has responded to those SMSs, these kind of stuff. And actually SMS is a very good way to interact with your customers, that they can read it and they can respond it. So there is some sort of interaction instead of just listening and just ignoring. So they opt certain options. We have got a very good experience with that we can also throw a lot of campaigns of our internal products to our customers and get advantage of that they opt, and there is a lot of revenue out of that products which we cannot sell through our website or other stuff. So by this we can add like multiple streams to our revenue. So if you continue.
Okay. So to kind of wrap it up here, there is for sure a lot of change happening in communications, no doubt. Even though the perception is, and which is for the most part correct, that the large telecoms for the most part don't really care about anything but selling their data plans and SMS plans and all that. Many telecoms around the world are under a lot of pressure to move, do something. On top of that, many enterprises are starting to really quickly figure out that they can do a lot of interesting things with contextual real-time communications without waiting on the telecoms to give them that permission, or without waiting on Huawei or one of the big equipment providers to give them their permission. There's a lot now available with open source on both the communication side, the analytics side, that allows for these things to start happening. And even though it's in sort of a beginning stages, the acceleration is really fast for people that are observing this space. And pretty sure in the next maybe 12 months or so, it'll become a lot more visible that communications is becoming programmable, available, friendly for developers, and not some crazy magical silo that nobody wants to touch and nobody wants to call and find out how it works. Okay, we can move on to questions.
My question was more on the query which you said, and you said you have a composite key of destination number and the time slot. So what was the granularity of the time slot, like days, hours?
Yeah, good question. So we experimented with that a lot to figure out what works for this marketing campaign type of application. And if I remember correctly, we ended up with a slot of 10 minutes.
10 minutes, okay. And you do a same day retry. You said for retry you don't delete it but move it to another table with some incremental time slot, right? Plus 10 something.
Yeah, so it'll stay in the same table for about a day.
Okay.
And then the next day, it'll be either sent across, or if not, it'll be moved on to the new day table, such that the old day table is within a few hours in the new day, completely unnecessary, and is dropped.
And when you have to delete it, what do you do?
We drop the whole table, the previous day table.
Okay. All right, thanks.
There's a question here. No, actually, it turns out that dropping a whole table actually frees up space, as opposed to deleting rows, which create tombstones, and it takes forever to delete, and it's super slow. Question.
Can you provide some details on your Cassandra infrastructure, like how many nodes, where you host, and stuff like that?
So I can share the volume of traffic. I think that's as far as we were allowed to share. Hundreds of millions of SMSs, billions of CDRs. That's how far we can go.
Any other questions?
I think we're good.
All right. Well, thank you guys very much.
Thank you.
Thank you.